All right, so we're on to chapter 8. So yes, we're doing chapter 8 now. And it's an intro into functions, which we're not going to really be getting into functions until a little bit later in the chapter. We're actually using the word functions, but all of this stuff kind of leads up to functions, and we're going to be doing a lot of finding slope and graphing and lines and all that fun jazz. All right, so 8.1 is equations in two variables. So we've had one variable equations that we've used. So like if you have like 2x minus 3 equals 7, so we can add 3 to that. Hopefully y'all remember. So we get 2x equals 10 and then divide by 2. So we end up getting x equals 5. Solved one variable equations. And then subtract 1, negative y equals 8, divide by a negative 1, so that gives us y equals a negative 8. So hopefully by now we can easily solve one variable equations. Well, solutions to one variable equations are single number of possibilities, even if there is more than one solution. Okay, so you only have one number for it. Whereas now, we're going to have two variables, and you have x and y in one problem. So you're going to have an answer for x that goes with a y. So if x is one thing, then y has to be the other thing to make it true. So let's just say, in this case, I'm going to say if x equals 1. So I'm going to just tell you x is going to equal 1. We're going to plug in 1 for x, and we're going to figure out what y needs to be in order for it to be, for this equation to be true. So I'm going to put, and I'm going to plug it in. So I'm going to say 4 times, but instead of x, I'm going to put 1, because we said x is going to be 1. Where did I get it? I just picked a number, okay? Just random number, okay? Plus 3y equals 10. So now I'm going to solve that. So that gives me 4 plus 3y equals 10. Subtract the 4, which will give me 3y equals 6. Divide by 3. So y equals 2. So if x equals 1, then y equals 2. Okay? So now, if we were to pick a different number, which I didn't leave myself a lot of room, let's just say if x equals 2. So we're going to say x is 2 this time. So then we have 4 times 2 plus 3y equals 10. That would be 8 plus 3y equals 10, which will be 3y equals 2, divided by 3. So that gives us y equals 2/3. Okay, so if x is 2, then y has to be 2/3 for this to be true. Now we're going to move on. There's, again, multiple possibilities for this. It's actually a line if you were to graph it, which we'll get to that in later chapters or later sections. But there are, you have to have two answers. You have to have the x, you have to have the y, and they have to go together. Now, we're going to look at this one. It's saying x times y equals 6. Well, there's a lot of answers for this, obviously, but I want to pick only ones that are whole numbers, okay? Whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, so on and so forth. So, let's think, what are the factors of 6? 1 and 6, 2 and 3, that's it. So we know that if x equals 1, then we know that y has to equal 6, because 1 times 6 is 6. So that's one set of answers. Or if we said x is 6, then we could have y equals 1, because again, 6 times 1 is 6. We also have x equals 2 and y equals 3, because that also equals 6 when you multiply them. And then we have x equals 3 and y equals 2. Those are the only whole number answers. So you can have much, much more without whole numbers. This one. Okay, let's think about this. Something plus something has to equal 4. Well, we know when we square a number, it's going to be positive. So these two numbers have to be positive. So the only numbers that would work would be 1 plus 3 is 4, or 2 plus 2 is 4, or 4 plus 0 is 4. Those are the only positive numbers. Okay, well, there's no way for me to plug in something to get 1 squared as a whole number, because we're using whole numbers. So 1 won't work, because that would be 1 squared, and then we'd have to have some other thing. But I know that if I plug in, if x equals 2, that's going to be 4. And 4 plus what equals 0? Well, we need it to equal 0. So if x is 2, y has to be 0, because 2 squared plus 0 squared equals 4, because that's 4 plus 0 equals 4. So that's one of our answers. We also could use y, well, no, not y. We can kind of flip them around. We could say x equals 0, y equals 2, because that's going to be 0 squared plus 2 squared equals 4. So that's 0 plus 4 equals 4. So those are actually only 2 whole number answers, because again, what squared is 2? Not a whole number. So now, another way to write this, we have x equals y equals. We can also write it as something called an ordered pair. It's called, and we're going to write that in a second. Solutions are pairs of numbers called an ordered pair. And it's written as x comma y. So for this one, my x is 2, so I put 2 first, and then a comma, 0 for my y, and that would be my ordered pair answer. For this one, again, x goes first, 0, y goes second, 2. 0, 2. 2 variable equations have infinitely many real number solutions. They're a line, okay? So infinitely many. That's why right now, it's nice to use some whole numbers, okay? So now, this says, state whether each ordered pair is a solution of 4x plus 3y equals 10. Well, I know that my first one in the ordered pair is my x. The second one is my y. So if I plug it into this equation, and it's a true statement, then it is a solution. If it doesn't work, then it's not a solution. So we have 4 times x, which is 4, plus 3 times negative 2, because that's y, equals 10. Well, minus 6 equals 10, and that is true because 10 equals 10. So that's true, so yes, it's a solution. That's a solution. So now we have 4 times negative 2, because that's our x, plus 3 times our y, which is 6, and that's going to give us a negative 8 plus 16, not 16, plus 18, which that equals 10, so we're good. So yes, that's a solution as well. Oh no, fractions, we can do this. 4 times 3 halves, just first we're plugging it in. That's our x. Our y is 4 thirds. Okay, think about this. Over 1, I can simplify that. And then this one, I can simplify that. So that actually leaves me with 2 times 3 over 1, which is 6. Or that leaves me 4 over 1, which is 4. 6 plus 4 is 10. So yes, that is a solution as well. And we gotta check our last one if it's a solution. And that will be 4 times 3 plus 3 times a negative 1, which gives us 12 minus 3, which is 9. So that is not a solution. No, it is not. Alrighty, so we have this equation. Right now, we don't know how to actually solve for equations other ways. So what we're going to do is we're going to be plugging in and guessing, and we're just going to be finding all the whole numbers. And we can easily find all the whole numbers because we just start plugging in numbers and see which ones work and don't work. Again, the lowest whole number is 0, so you're not using any negatives. And you can't have any fractions or decimals or whatnot. So what I'm going to do is I'm going to kind of do a little column to help me. X, Y. So let's just say if I plug in 0 for x, okay? Well, that's going to be 0 plus 1, which is 1, times y, which equals 3. So y would have to equal 3. So that would work. So this one works. Now, if I have x is 1, so 1 plus 1 is 2, times what equals 3? Well, that's not a whole number, so I'm just going to cross it out because it doesn't even matter, because I know it's not going to be a whole number, and we're only looking for whole number answers. So 2 plus 1 is 3, times what equals 3, and I know y would have to be 1 for that case, so that works. We get 3 plus 1 is 4, 4 times what is 3, and that's not going to work either. Now, if you notice, I have got 1, 2, 3, 4. It keeps going up by 1 every time because it gets added to 1. Well, I'm going to then get 5, 6, 7, 8, and I know that 5 times, like all these numbers that are bigger than 3 aren't going to be multiplied by a whole number to get 3. It would have to be a fraction. So therefore, I can stop. I'm done. There's no more possible solutions. So my answers for this are 0, 3 and 2, 1. Alrighty. Last problem. Dawn spent $13 on pens and notebooks. The pens cost $2 each and the notebooks cost $3 each. How many of each did she buy? Hint, write a 2-variable equation to help you. So I'm going to say that X is going to equal my number of pens. X equals number of pens. Always good to define your variable. And Y equals number of notebooks. So therefore, I know if I multiply the cost of a pen, which is $2, times however many pens, which is X, because if I bought 10 pens, 10 times 2 is $20, okay? Plus, however much a notebook costs, which is 3, times however many notebooks I have, which if I had 5 notebooks, 3 times 5 is $15. We add those up, how much we pay for each one of them, and that's going to have to be equal a total of 13. So, there we go. So therefore, we have our equation, and think of this. We can only have whole numbers. Why? Because I can't buy half of a pen, or 2.5 pens, or 2/3 of a pen. So they all have to be whole numbers. So we're gonna kind of do our chart again and see which ones work. So again, you can start with 0 because you can buy no pens. Okay, so if she has 0, then I'm gonna use this over here. 2 times 0 is 0 plus 3y equals 13. Well, that's going to say that, it's going to say that 3y equals 13. If you divide that, that is not going to divide evenly, so therefore that can't work. Okay, no bother of finding out what it is because it's not a whole number. Okay, now I'm going to plug in 1. So 1 times 2 is 2 plus 3y equals 13. I'm going to subtract the 2 from both sides, so that gives me 3y equals 11. Well, that's not going to be a whole number. 3 times nothing is 11. That's a whole number, so no point of figuring it out. Now I'm going to look at 2. 2 times 2 is 4, plus 3y equals 13. I'm going to subtract 4 from both sides, so that gives me 3y equals 9. Well, 3 times 3 is 9, so y has to be 3. So that one's going to be one of our solutions. Now we got to keep going because we don't know. There might be another combination that works. So 3. 3 times 2 is 6, plus 3y equals 13. That's going to tell me that 3y, we're subtracting 6 from both sides, equals 7. And there's nothing that y can be a whole number to equal that, so that one's not going to work. We have 4, so 4 times 2 is 8, plus 3y equals 13. Which gives you, subtracts that, that's 5, so 3y equals 5. And again, that's not going to be a whole number. 5. 5 times 2 is 10, plus 3y equals 13. Subtract the 10, so 3y equals 3. Oh, that means y is going to equal 1, so that works. And let's keep going. There might be some more. So 6. So 6 times 2 is 12, plus 3y equals 13. Subtract 12, so that's going to say 3y equals 1. Well, again, not a whole number. Now, this is the point where I get to where I can stop. Because if I pick 7, 7 times 2 is 14, and that's greater than 13, and that's going to give me a negative number, and I can't use negative numbers because that's not a whole number. So therefore, these are the only possible whole number choices that I could have used. So therefore, the answer is either 2, 3 or 5, 1. And I can keep them as an ordered pair because I already labeled. I already know which one goes with which. 2 goes with number of pens, and 3 goes with number of notebooks, or 5 goes with number of pens, or 1 goes number of notebooks. And there you have it.